In this lecture, we will be discussing about the quartiles, how we calculate the quartiles. I will tell you the step-by-step method of calculating the quartiles, why we use quartiles. Then I will give you a practical example, and then we will discuss the question, which is forwarded to me multiple times, that why this answer in this question and why not this answer. So we will discuss why that particular answer. So let's start with this lecture. What are quartiles? A quartile is a statistical term that describes a division of observations into 4 defined intervals based on the values of the data and how they compare to the entire set of observations. Quartiles are organized into lower quartiles, median quartiles, and upper quartiles, like over here. Q1, lower, Q2, median, and Q3 is the upper quartile. Why we use those? What is the importance? Quartiles are used to understand data distribution, identify outliers, and compare different data sets. An outlier is a value that is much smaller or much larger in a set of data. So let's see what is the step-by-step method. Step 1, firstly, order the data. Arrange the data points in the ascending order. Step 2, find the median. Median is the middle value of the data set. Step 3, divide the data into halves. Divide the data set into 2 halves based on the median, and then find the first quartile, that is, calculate the median of the lower half of the data. Q2, or the second quartile, will be the actual median. And then find the third quartile, calculate the median of the upper half of the data. Now let's see this example. These are the test scores of students from a class, and we have to find the quartiles. So this is the data set. We have arranged the data set into in an ascending order. 78, 82, 85, 86, 88, 90, 91, 92, 93, and 95. So we will get the median. Actually, it is an even set of numbers. So we will go for the middle 2 numbers. We will add those, divided by 2 to get the median. I have explained that to you in one of the lectures as well. Now we will go for the lower half, from 78 till 88. And the upper half is 90 to 95. The median for the lower half is 85. That will be the first quartile. Then second quartile would be the median, actual median, that is 89. And third quartile will be 92, which is the median of the upper half. It is a simple method. Well, the interquartile range is the difference between the third quartile and the first quartile. Third quartile and the first quartile. This is the interquartile range. Outliers, these are the data points that are more than 1.5 times the IQR value, Q1, or 1.5 times above the Q3, the third quartile. Box plot, this is the box plot. Box plots are used. These are the graphical representation of quartiles showing the median. This is the median. This is the first quartile. This is the third quartile, and then the outliers on both the sides. Now, what is our question? Let's see and how we are going to solve it. It is not a simple question. Quartiles of diastolic blood pressure readings of 400 dental patients. The graph shows the distribution of the diastolic blood pressure of 400 dental patients. What would be the values of first quartile, second quartile, third quartile from this graph for observed values of 400 patients? So our observations will be 400. This is the frequency, and these are the blood pressures for various observations. So we have kept those in the bin, and these are the bars which are showing you how many times we have observed that particular blood pressure. To estimate the values of Q1, Q2, and Q3 from the histogram, we follow these steps. First of all, we know that the number of observations is 400. Determine the positions of Q1, Q2, and Q3. Q1 is the 25th percentile, the value below which 25% of the observations lie. We are talking about observations, not the frequency. Q2 is the median or the 50th percentile. And Q2 is that the second quartile. Q3 is the 75th percentile, the value below which 75% of the observations lie. Now the detailed cumulative frequency calculation. This is the approximate. Count the number of observations in each bin and sum them cumulatively until you reach the positions for Q1, then for Q2, and then for Q3. For example, if each bin width is 5 millimeter of mercury, we can approximate the number of the observations in each bin based on the height of the bars, assuming each bar's height is proportional to the number of observations. The histogram shows frequencies of approximately 70 to 75 milligram of mercury around 22 to 25 observations. 75 to 80 millimeter of mercury around 30 to 35 observations. 80 to 85 millimeter of mercury around 35 to 40 observations. 85 to 90 millimeter of mercury around 30 to 35 observations. 90 to 95 millimeter of mercury around 25 to 30 observations. So we sum these and we will get the cumulative frequency table that helps pinpoint the exact quartile positions. This is the cumulative frequency. Here we can see the approximate frequencies. And then by adding those, we will get the cumulative frequency. Like say, for instance, 50 to 55, we have only 2. Then 55 to 60, only 3. But the cumulative frequency here will be 5. So in the same manner, we will be adding it up. And 70 to 75, we have 35. 75 to 80, we have 70. 80 to 85, we have 100. Why I have put those in bold, I will explain that to you in a bit. So we have actually 135 different data points. Step 1, determine the position of Q1, Q2, and Q3, total number of data points, n, that is 135. Position of Q1, n, that is the number of observation plus 1 divided by 4 is equal to 135 plus 1 divided by 4. Our answer will be 34. Means we will be going to the 34th data point to get our first quartile, which will be close to 35 in our cumulative table here. Close to 35, 34 is very close. So it will be between 70 to 75, first quartile. Second quartile, position of the Q2, that is actual median, n plus 1 divided by 2, not by 4. That was by 4. It is by 2. So 135 plus 1 divided by 2, that is 68, means 68th data point, which will be close to 70 in our cumulative frequency table. 68, we do not have 68, but it is very close to 70. So between 75 to 80 is our Q2. And position for the third quartile, we will follow this formula. N plus 1 whole multiplied by 3 divided by 4. So 135, which is our total number of the observations, plus 1, then that 136 is going to be multiplied by 3 divided by 4. Our answer is 102, means we have to go up to 102nd data point, which will be close to 100. 102, close to 100 in our cumulative frequency table here, which is between 80 to 85. That is our third quartile. So step 2, identify the corresponding diastolic blood pressure values for these positions using the cumulative frequency distribution. I have just showed you Q1 will be between 70 to 75 millimeter of mercury. That is the 34th data point. 68 data point for Q2, that is between 75 to 80. And Q3, that is 102nd data point, Therefore, Q3 corresponds to 80 to 85 millimeter of mercury. Determination of the position Q1, 0.25, because we have 400. So it will be the 1/4 number of the observations, which will be the 100th observation. Q2 position will be the 200th observation, and Q3 will be the 300th observation. Total number of observations are 400. So Q1, look for the bin where the cumulative frequency reaches or exceeds 100. From the graph, it is somewhere between 70 to 75. Q2, it will be just 200, and it will be between 80 to 85, which we can even see from here in the middle. Then Q3, look for the bin where the cumulative frequency reaches or exceeds 300. From the graph, this appears to be around 85 to 90 millimeter of mercury. So summary of the quartiles: Q1 approximately 70 to 75 millimeter of mercury, which is close to the answer 73. Q1 would be close to 73. So between 73 is lying between 70 to 75. Then Q2, if they will ask you about Q2, it will be lying somewhere between 80 to 85. They can ask you about 82, 83, whatever. And Q3, it is approximately between 85 to 90, anywhere between that. So they can ask you about 86 or 87. So you should be prepared for that as well. So over here, we are done with this lecture, and soon I will be seeing you again with another lecture, same type of lecture. Send me your queries, and definitely I will get back to you by these type of videos where I will be explaining all your questions, your queries in a detailed manner, so that things will be easier for you to understand. Thank you very much.